computer.
Yeah,
Okay,
that's
got
fine.
that. Okay.
Okay.
So we discussed about the ionic compounds, right?
Yes.
After the ionic compounds, what is the next? Some compounds such as stable salt, okay. Force of attraction holding the two atoms, okay, we discussed this. The properties of the ionic compound. Mm, okay, yeah. So when we talk about the ionic compounds, they are hard and brittle,
Okay.
right? So we know the
Yeah.
meaning of hard and brittle, right?
Yes.
Okay.
Like
S-
they like break apart.
Brittle means they can easily break.
Yeah, and then hard is just yeah.
Yeah. So they have relatively high melting and boiling point. So basically, if you have ionic compounds, they will have very high melting and boiling points.
Okay.
Okay. They can conduct electricity, but
Mm,
only when they are in the molten state or they are dissolved in water.
okay.
Correct?
Yes. I
So,
mean,
what are the properties? They are hard and brittle,
um,
they are
yeah.
relatively high melting and boiling points,
Mhm.
conduct electricity if they are molten liquids. Molten liquid means what?
They can like liquid state, like
Okay,
if
so
they're
basically,
liquid.
what you do is you heat these solids, the ionic compounds, if you heat them, okay, to a very high temperature, they will get converted to liquid, and that liquid can easily conduct electricity
Okay.
because when you heat them, they have free ions.
Okay.
Okay, does that make sense?
Yes.
So, only when they are molten liquid, they have free ions. When they are dissolved in water, they have free ions.
Okay.
So, when they have free ions, they can conduct electricity.
Okay.
Okay, now you must be aware of this term that is electrolyte. So, electrolyte is a compound that dissolves in water, producing a solution that conducts electricity.
Mhm.
Okay,
Yeah.
that's done. Okay, we already discussed formation of the ionic compounds. We took the example of sodium, right?
Yeah.
Sodium forms a cation by losing an electron. Chlorine forms anion by gaining an electron. Why sodium forms a cation? Because
It
it,
loses the electron. Also.
it loses an electron, that's right.
Mm-hmm.
But what happens when it loses an electron? It gains a stable electronic configuration
Okay.
because the outermost shell has now
Uh.
8 electrons,
Okay.
right?
Yeah.
Sodium has a electronic configuration that is 281. When
Okay.
it loses one electron, it forms a cation with electronic configuration 2 and 8.
Okay.
Correct?
Yeah.
Whereas in case of chlorine,
Mhm.
we discussed this, 17 is the number, atomic number, electronic
Mm.
configuration 287. When it gains one electron, what happens? The
Because
electronic configuration is 288.
mm-hmm.
That means again its outermost shell has 8 electrons, right?
Yes.
So that gives chlorine anion
Mm-hmm.
additional stability,
Okay.
right?
Yes.
And now because they are charged, where is it? Now they are charged.
Yeah.
So they form the ionic compound,
Okay.
correct?
Yeah.
Any doubt?
No.
So formation of ionic compound was discussed. Magnesium ionic bond, the electrostatic force of attraction between a positive ion and a negative ion, a type of chemical bond, right?
Mm-hmm. Should I write that down?
Yeah, take it down.
Okay.
Done?
Yeah.
Okay. Now, so have you learned about Lewis structures? Did I discuss that in the last class?
Yes.
We know how to draw
Um,
the Lewis structures, right? Okay. And we know how to find out the valence electrons. Can you remind me how do we find the valence electrons?
it's through, wait, I think the families, like sorry, the vertical,
The group numbers from the
yeah,
periodic table,
the group numbers.
right? So if we have group 1, you have one valence electron,
Mm-hmm.
group 2, two valence electron, group 3,
Three
you
valence,
have,
uh, three valence electrons,
so
and then
you don't have group 3, you have group 13.
yeah,
You ignore group 3 to group 12 because those are the transition
yeah.
elements,
Okay,
right? So 1 has one valence electron,
okay.
2 has two valence electrons, then 13 has three valence electrons,
Mm-hmm.
14 has four valence electrons, 15 has five valence electrons, 16 has six valence electrons, 17 has seven valence electrons,
Okay,
and 18 has eight valence electrons.
okay,
So the group number will help us understand how many valence electrons are present, which will help us draw the Lewis structure.
okay.
Correct?
Yes.
Now, the next part is the crystal lattice. Let us understand that. So this structure over here, okay, is a crystal lattice.
Okay,
So basically, what happens is you have, uh, let us say you have chlorine, the anions. Generally, the anions are larger in size. Okay. So
okay,
the anions, imagine them as forming the, uh, let us say this is a cube. Mm,
okay,
Let me explain. So we have, let us assume that there is a cube.
okay.
Okay. Right. And at each cube, there is a chlorine atom or chlorine ion. Does that make sense?
Yes.
So we have total one, two, three, 4, 5, 6, 7, and 8 chlorine ions.
Okay,
So this group of 8 chlorine ions form a crystal lattice.
okay,
Okay. And what we have is we have repeated units of this crystal lattice. Okay. So let us say this is one crystal. You will have another crystal that is attached next to it. Okay. Then you have another crystal that is attached next to it. So this is how you have a complete structure of the ionic compound.
okay.
Do you get me? So what
Yeah,
is a crystal lattice?
it's like I
It is the simplest arrangement of the ions.
okay, so the crystal.
It is the simplest arrangement of the ions.
Okay. Sim
Okay.
arrangement.
Which is repeated continuously.
Okay.
So imagine like when you play Lego. So or where let us say we have the cubes and we arrange the cubes next to each other, right?
Mm-hmm.
So a group of cubes together
Yeah.
forms a crystal lattice.
Okay.
Okay, any doubt?
No.
Okay, so structure of ionic compound, that's done. Now, okay, now why, like they are hard, that is clear because they are the electrostatic force of attraction is extremely strong. But why they are brittle is because let us say this is your crystal.
Mm-hmm.
Okay, so when a force is applied, let us imagine. Okay, let us say think that this is the positive and this is negative. Okay, so when force is applied over here, think that the positive and the positive will come closer to each other. The negative and negative will come closer to each other. And if that happens, what happens to the to the positive and positive charge and negative charge?
They repel.
They repel, and that makes a ionic compound brittle.
Okay.
Any doubt?
No. Mm,
So basically, these layers they can slide on each other
okay.
when force is applied. And if the like charges come in front of each other, they repel and they easily break.
So when force is applied, the positive and the positive and positive I ions like come like get pushed closer together, which causes them to repel, and the
Yes,
negative and negative ions repel from each other, causes it to have like a brittle consistency.
yes.
Okay.
So that's done. Okay. Now here this is trying to explain us that why ionic compounds can conduct electricity.
Okay.
Okay. So we have the crystal of sodium chloride. Okay, I didn't mention this that when you have the crystal lattice, the the cations which are smaller they go and fit into the void spaces. So imagine it this way. When we have the crystal like the anions forming the cube, okay, there
Mhm.
is void space that is generated. Okay,
Okay.
so your the backbone is the anion. Okay, the skeleton is the anion, and wherever there is void space, the cations can go and fit into that. Does that make sense?
Okay.
Okay, now we know water is polar in nature, correct?
Yeah. What does that mean? Sorry.
Okay, so water has what do you say? It has partial positive and negative charge on its bonds.
Okay.
Okay, so for now, and remember that water is polar. That means hydrogen is carrying a positive charge, partial positive charge. Oxygen is carrying a partial negative charge.
Okay.
Okay, when we do the Lewis structures in detail for the compound, we'll understand what exactly polarity is.
Okay.
But for the sake of this discussion, remember that water is polar. Polar means hydrogen has a partial positive charge, oxygen has a partial negative charge.
Okay. I'm gonna write that down.
Yeah, I'll be back in a minute.
Okay.
Okay, I'm back.
Okay. I'm done.
So you wrote water is polar in nature.
Yes.
What
Water
does
is
polar
polar,
means?
and polar means that hydrogen has a partial positive charge and
Right,
oxygen has a partial negative charge.
right. So the covalent bond is actually polarized.
Okay.
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 Now, when your crystal, that is sodium chloride, the ionic compound, is dissolved in water, what happens is the chlorine, which is negatively charged, right,
Yeah.
is attacked by water.
Okay.
The cations, which are positively charged, is also attacked by water. But if you see the attack, the chlorine is attacked from the hydrogen side.
Mm-hmm.
Okay, and the reason is very simple, because there is a partial positive charge on the hydrogen, so it will definitely attack the negative center,
Yeah.
correct?
Yeah.
Whereas the cations are attacked by the oxygen.
Okay.
Does that make sense?
Yeah.
Okay, so when they attack, what they try to do is they try to remove them from the crystal.
Mm-hmm.
Okay, is that clear?
Yes.
And what they do is they surround the cations and the anions,
Okay.
and they stabilize the cations and the anions. Does that make sense?
A little bit.
So sodium, so basically what happened, it was in a crystal form. You
Mm-hmm.
added it to the water. In
Mm-hmm.
water, what happened? Sodium and chlorine got separated.
Yeah.
So when they are separated, they need to be stabilized. So they
Okay.
are stabilized by the water molecules.
Okay.
How they are stabilized? The positive charge is stabilized by the negative charge of the oxygen,
Okay.
whereas the negative charge of the chlorine is stabilized by the positive charge of the hydrogen. Does that
Mm.
make sense?
Yes.
Okay. This state is called as hydration.
Okay.
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 Yeah.
So basically, after the ionic compound is dissolved in water, the ionic compound doesn't exist.
Okay.
What exists is the ions,
Okay.
right? And when we have the, what you say, uh, electric current connect or the circuit connected to it, what happens? We have the cathode and we have the anode,
Mm-hmm.
correct?
Yeah.
So the cations, oh my bad, this will be the anode and this will be the cathode.
Okay.
Okay, so the cations are attracted to the cathode and the anions are attracted to the anode.
Mhm. Okay.
Does that make sense?
Yeah.
And this is how the ionic compounds are able to conduct electricity. So if you see in this figure, there are no ions present, correct?
Yeah.
So if there are no ions, what happens?
It.
No electricity is conducted.
Okay.
But if there are free ions, electricity is conducted.
Okay.
So any ionic compound, when it is dissolved in water, what happens?
It electricity is able to be conducted
Why?
because the negative charged particles move to the cathode while the
Negative, that negatives are the anions, they move to anode.
Mhm.
Cations are positive, they move to cathode.
Okay.
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 Okay, done. So molecular element. Now let us understand what are molecular elements and compounds. So for molecular elements and compound, let us first understand what are covalent compounds. Okay, or covalent bonds. So covalent bonds are formed by sharing of electrons. Okay, they are formed by sharing of electron. Okay, so example, if you have chlorine 287, chlorine 287, correct?
Yeah.
Now each of the chlorine needs one electron. Does that make sense?
Yeah.
So what happens in chlorine is, so if we draw the Lewis structure, so we know how to draw the Lewis structure, 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7, correct?
Yeah.
And another chlorine, 1, 2, 3, 4, 5, 6, and 7. So if you notice in the structure, this and this, they are not paired,
Mhm.
correct? So what
Yeah.
happens is the chlorine molecules come closer to each other and the unpaired electrons are shared with each other.
Okay.
Okay, this is how now the two chlorine atoms have 8 electrons in the valence shell
Okay.
by sharing one electron. So now the electrons are not getting transferred but they are getting shared. In ionic compound, they were leaving the octet and entering in the another octet. Oh, sorry, they were leaving the orbit and entering another orbit.
Okay.
In this case, they are not leaving the orbit. The orbits are coming closer and they are sharing the electrons.
Okay.
Is that clear?
Yeah.
So covalent compounds are formed
Non-metals and metals. No, wait,
by
those are two non-metals. No, the other ones
yes,
were
that's
non.
correct.
Yeah,
But
the other
how
one.
are they formed?
The sharing of electrons
Uh, that's right. Why do they share electron?
because both need uh they both need one electron, like,
They
and so they
both
share
need one electron. And why they both need one electron?
because they want to achieve full stability,
That means
a full outer shell.
full outer shell means the octet needs to be complete.
Oh,
So remember the term octet. It is extremely important.
okay.
Okay. So can you write down these terms now? What is a molecular element? So we understood what are the covalent compounds. So molecular element, a pure substance composed of molecules made up of two or more atoms of the same element. So molecular elements, they are made up of same element. Diatomics made up of two atoms. Molecular compounds made up of more than two atoms, two non-metallic atoms. They can be same or different.
Mm,
So basically, when we say compound, they are different.
Okay.
Yeah. So this is done molecular compound. So molecular element, same element, more than two atoms,
Okay.
two or more than two. Diatomic, two atoms. When we say diatomic, they can be same element or two different elements.
Mm-hmm.
Molecular compounds, two or more atoms and non-metallic atoms. And when it is a compound, they are of a different element,
Okay.
right? For example, HCl. So let me give you examples over here. So here it is HCl. It's a molecular compound. Diatomic, let us say H2. Okay.
Yeah.
Molecular element O2, or you can also call O3.
Okay.
O3 is ozone.
I'm a bit confused.
Sorry,
Sorry, I'm a little bit confused a bit. Like
confused with what?
the molecular element, like it's the same element, but it's just like more of the atoms. So that's
Sorry, can you repeat? I didn't
confusing.
hear you clearly.
It's like it's the same like it's the same substance, like it, I don't know how to explain it, but it's
Okay.
just
When
more.
we talk about molecular element, so what are elements generally? Anything that is present on the periodic table is an element,
Okay, yeah,
right? So sodium, chlorine, so let us say hydrogen, helium, all of these are elements,
okay,
correct?
yeah,
Okay. What are molecular elements now? Molecular elements are those which exist as more than one atom.
okay.
For example, Hofbrinkel. Have you heard of this term?
Oh yeah,
Hofbrinkel?
okay, yeah. Now I remember.
Yeah. So
Yeah,
Hofbrinkel is what? Hydrogen, bromine, hydrogen, oxygen, fluorine, bromine, chlorine, iodine,
yeah.
nitrogen, right?
Mm-hmm.
So these Hofbrinkel, they are elements, but these are molecular elements which are diatomic in nature,
Okay,
right? So
yeah,
if we say hydrogen gas, it is not just hydrogen, but it is H2.
okay,
Does that make sense?
yes,
That is what is a molecular element.
okay,
Okay.
mm-hmm.
Diatomic means two atoms.
Okay,
It could be same atom, like, it could be different. For example, the example for like in the example below here, hydrogen. Can you see my cursor moving?
yes,
So the hydrogen, these are two atoms of the same element.
mm-hmm.
So it is diatomic. We can also call it as molecular element.
Okay.
If you see another example, that is HCl.
Mm-hmm.
Even that is diatomic,
Mm-hmm.
but
But
it is a molecular compound
okay.
because there are two different elements
Okay. That
in the
makes sense.
molecule.
Yeah.
Correct?
Yeah.
Mm. So property of molecule, covalent bonding within the molecules, molecular elements. So you can now copy this part. Covalent bond, the bond that results from sharing of a pair of electrons by two atoms. We discussed this.
Mm.
You remember?
Yeah.
Then bonding electron, the shared pair of electron is actually the bonding electron.
Okay.
Okay, can you write down this? So covalent bond, bonding electrons, and bonding capacity.
Okay.
Then
Almost. Okay.
done.
Yeah.
Okay. Now bonding capacity is a Lewis symbol of an atom. Okay. For now, check over here. If the group number is one, the number of valence electrons is one,
Okay.
right?
Yeah.
Bonding capacity is one.
Okay.
If the group number is 14, number of valence electrons are 4, bonding capacity is 4.
Okay.
If we have group number 15, then the number of valence electrons are 5.
Yeah.
Bonding capacity is 3.
Okay.
Why? Because the paired form or the paired electrons do not form bond.
Okay.
Only the unpaired electron form bonds.
Okay.
Okay. When we have 16, 6, if you see the Lewis structure, there are two unpaired electrons. Correct?
Yeah.
So that forms a bond. When it comes to 17, that is halogens, 7 valence electron, 1 bonding capacity because there is only one unpaired electron.
Yeah.
Can you please take this table, like copy this table?
Yeah. I'm drawing it right now.
Yeah.
So, Okay.
So molecular compounds, we discussed this. Can you draw this HCl?
Okay.
Then,
Yeah.
so are you done with the structures? Try and understand the molecular compounds and the structures that we draw for the compound.
Okay.
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 Water, check the Lewis structure. Like I told you, only the unpaired electrons are forming bond. So oxygen, we know, have 6 valence electrons, right?
Mm-hmm.
1, 2, 3, 4, 5, and 6. And when we draw the Lewis structure, we know that we can go either clockwise or anti-clockwise with the valence electrons,
Yeah.
right? So I went over here in a clockwise manner, and I have 2 unpaired electrons. And
Yeah.
if we draw hydrogen, it has 1 unpaired electron, correct?
Yes.
So that's how we get the structure of water.
Okay.
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 And for carbon dioxide, if you notice, it has 4 unpaired electrons. One, two, three, four. Carbon has 4 unpaired electron.
Yeah.
Oxygen has 2 unpaired electrons, correct?
Yes.
So they share one, right?
Yeah.
Is that clear?
They're they're like double strand with carbon. Wait, I don't.
Yeah. So
Okay.
now if you notice, this is the structure that happens, right? But
Yeah.
now still you have 1 unpaired with oxygen, 1 unpaired with carbon,
Okay.
1 unpaired with carbon, 1 unpaired with oxygen. So
Yeah.
what they do now is they form something called as double bond.
Okay.
Oh, my bad. And then you have those 2 lone pair electrons. Correct?
Yeah.
Can you draw the carbon dioxide?
Yeah. I drew it. Okay. So it only forms like bonds with the lone pairs.
No, lone pairs never form. Like they don't form bonds.
Okay. So it forms with only when there's like a pair.
Unpaired form bonds.
Pardon?
Only unpaired electron form bonds.
Okay.
Paired don't need to form a bond.
Okay.
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 Am I clear with what I said? Paired or lone pairs don't form bond.
Yes.
Only unpaired forms bonds.
Okay.
Okay. Now, how do we draw the Lewis structures for a molecular compound? Now, if you check, draw a Lewis structure and a structural formula for a molecule of methanol, that is CH2O. So arrange the symbol of the element in their compound so that the element largest bonding capacity is in the center.
Okay.
So carbon has the largest bonding capacity,
Okay.
right?
Yeah.
Spread the surrounding atoms as far apart as possible from the central atom. Okay. Count the valence electrons for each, right?
Yeah.
Hydrogen there are two, so we multiplied that by two. So the
Mhm.
total valence electrons are 12, correct?
Yeah.
After that, what we do is we give the pair
Okay.
so that they share.
Okay.
Okay, so just check. So you draw the shared pair of electrons.
Mhm.
Okay, and then you complete the octet. Okay,
Mhm.
now determine how many electrons are still available. If you notice, okay, let me do it. So when we first, let us calculate the valence electrons. Carbon has 4 valence electrons, oxygen has 6 valence electrons, hydrogen has 1 valence electron, correct?
Yes.
But there are, in CH2O there are two hydrogens,
Mhm.
one carbon, one oxygen. So you have 4, 6, 2. So you have 12 valence electrons. Is this clear?
Yes.
Right? Can you write down that?
Okay. Like for above, how do we know that carbon has like the strongest bonding capacity?
Sorry.
Like above when like drawing the diagram, how do we know that like carbon has the strongest bonding capacity?
So it can for 4, right?
Yeah.
4 means 4 bonds can be formed. So when you have, okay, you remember valence electrons?
Yeah.
For group 1 there is only one valence electrons.
Yes.
Bonding capacity is 1.
Mm-hmm.
Group 2 valence electrons are 2.
Yeah.
Bonding capacity is 2.
Okay.
Group 3, 3 valence electrons. Bonding capacity is 3.
Mm-hmm.
Group 14, sorry, group 13, 3. Group 14, 4.
Mm-hmm.
4 valence electrons, bonding capacity is 4. So the summation should be 8.
Okay.
Is that clear?
Yeah.
Either you can lose 4 electrons or you can gain electrons so that the summation is 8.
Okay.
Do you get me?
Yeah.
So the rule is, you might have learned this in the school in grade 10. So if you have 4 electrons, you can either gain 4 electrons or you can lose 4 electrons.
Yeah.
If you have 5 electrons,
You have to
right?
lose
The
four.
rule is it's easy to gain 3 electrons.
Okay.
6, easy to gain 2 electrons.
Mm-hmm.
7, easy to gain 1 electron. But
Okay.
if you have 3, then it is easy to lose 3 electrons.
Okay.
Does that make sense?
Yes.
So that the octet is getting complete.
Okay.
So the bonding capacity is decided based on the number of electrons that you can lose or gain.
Okay. Okay. I wrote that down.
Done.
Yep.
So is this clear why carbon has bonding capacity that is maximum?
Mm-hmm.
Okay.
Yep.
So that means your carbon will be the central atom.
Okay.
Then you draw the other three atoms next to each other. Okay.
Mm-hmm.
Now from the 12 electrons that you have, you will give one pair in between each atom. Okay.
Okay.
Right. So
Yeah.
now out of 12, 6 electrons are done. 6 electrons are remaining. Correct.
Yes.
Now out of these 6 electrons, hydrogen needs only 2 electrons because it doesn't have a second orbit. Right.
Yeah.
Hydrogen will be stable even if it has 2 electrons.
Okay.
Right.
Yep.
Oxygen on the other hand needs 6 electrons to be stabilized.
Okay.
So you give the remaining, you complete the octet of oxygen. But as you complete the octet of oxygen, you realize that carbon has only 6 electrons.
Okay.
Correct?
Yeah.
If that happens, you can transfer a pair to the center from the oxygen.
Okay.
So now the structure will be you have carbon, right?
Mhm.
And this becomes your structure, Lewis structure. Okay?
Okay. So in order for carbon to be stable, it shares two electrons with oxygen? Like,
Sorry?
so for in order for carbon to be stable, it forms like two bonds with oxygen, like not two
Yeah, it
bonds
forms
with.
a double bond with oxygen so that there are 8 electrons in
Okay.
carbon. So
Oh.
if you see now, when the pair is transferred, now
Mm-hmm.
calculate this 1, 2, 3, 4, 5, 6, 7, and 8. So carbon has 8 electrons, oxygen has 8 electrons, right?
Mm-hmm.
And hydrogen has its 2 electrons. So all of them have their octet or duplet completed.
Okay. Okay, I copied that. Okay. Okay.
Okay. Now, can you try CCl4
CCl4.
and share the image with me on WhatsApp?
Okay. So there's like four chlorines, right?
S-
Okay.
CCl4, carbon tetrachloride.
Okay. Okay, I'm sending it.
Done?
Yeah.
Can you share it on WhatsApp?
Yes, I sent it.
Sent it. I haven't received it yet. Received. Uh, okay. When you started, if you notice one of the like one of the chlorine, you have written as carbon.
Oh, yeah.
Did you check that?
No,
Yes.
yeah,
Like when you
this is,
completed the structure, you made like you corrected the mistake.
oh, yeah, I'll fix it.
Yeah. One, two. Yeah, that's fine. The structure is fine.
Okay.
Okay. Now I want to give you one more example. Um, that is, let us try. I gave you CCl4, right?
Pardon?
I gave you CCl4.
Yes.
Now try HNO3.
HNO3. Okay.
Okay, we'll do this. Like it is difficult. Take 3 minutes. Figure it out if you can do it. Otherwise, I'll help you. It is difficult. It is not that easy. Hello? Hello?
Hello?
Leanne?
Yeah, sorry, my mic was off. I said I was a bit confused
Okay,
on
yeah,
this
no,
one.
it's a difficult one, that's fine.
Yeah.
So let us start with our first rule,
Okay. Should
hydrogen.
I show you what I got so far, or should I just leave it?
It's okay, like you can share the image with me.
Okay.
So hydrogen has one, like we have HNO3, right?
Yeah.
Okay, so hydrogen, one electron, one valence electron, uh, one nitrogen, we have
Mhm.
five valence electrons.
Yeah.
Oxygen, we have six valence electrons. So
Yes.
1 into 1, 5 into 1, 6 into 3, correct?
Mm.
So
Yeah.
you have 1, 5, and 18.
Yeah.
So you have total 24 electrons,
Yes.
correct? Now, when you have, so the bonding capacity of nitrogen is the maximum,
Mhm.
you will surround it by oxygen,
Yes.
okay? Hydrogen should be ignored. So anytime remember that because you have hydrogen, if it is hydrogen and fluorine, they need to be considered last,
Okay. Mm.
okay?
Yeah.
Because they are monovalent,
Okay.
okay? Only if the octet is not getting complete, then we'll consider them,
Okay.
okay? So now let us understand that over here, because nitrogen has bonding capacity of 3, I'm just considering only 3 oxygens around it,
Okay.
okay? So now let us give the shared pair of electrons,
Okay.
correct?
Yeah.
That's done. 6 is done. So out of 24, 6 is done. 18 are remaining. I'll complete the octet of oxygen.
Okay.
Okay. Now, if you notice, nitrogen has only 6 electron. Oxygen has 8 electrons. So what I'll do is I can transfer one lone pair to the center.
Okay.
Correct. So nitrogen now will have 8 one lone pair, and it has uh my bad. Nitrogen will have a double bonded oxygen,
Mm.
single bonded oxygen, another single bonded oxygen, correct? And three lone pairs here, three lone pairs here, and two lone pairs here.
Yes.
Now, where you have three lone pairs, there you will give hydrogen. Any you can choose.
Okay.
Okay,
Okay.
so this is your Lewis structure of HNO3.
Um, so you can just give the oxygen like a full like outer circle, like a full
Yes,
circle?
oxygen will have the octet complete. Yes.
Okay.
Would
Does
you
that
like to try CO2?
yes, please.
Yeah, that is relatively easy.
Okay. Okay. So carbon's in the middle and then it forms double bonds with oxygen.
Yes.
Okay. I sent the photo.
Yeah, that's fine. Okay. So I got the image and it's correct.
Mm.
Okay, so now let us see if okay, let us try uh pH 3.
Okay, I'm sending it.
And then try C2H6.
C2H6.
Yeah, that's correct. pH 3 is correct. Perfect, you got that right.
Okay.
And you smartly decided to put carbon next to each other because both of them have the same number of bonding capacity.
Mhm.
So that was a good one. I thought you will get that wrong,
No,
but you got that right. Good job.
thank you.
Okay, so Lewis structures. Fine. So when you have a polyatomic ion,
Mm.
there is a negative charge over here, ClO3 minus. So when you have a negative charge, you will add one electron, like depending upon the negative charge. If it is one negative, one electron, two negative, two electron, three negative, three electrons.
Okay.
Okay.
Yeah.
Okay. Let us do this. PO4. No, I don't want to go there. Okay, let us do the ClO3 minus. Okay.
Yeah.
So because there is one negative charge, there is one electron that is added to the total valence electrons.
Okay.
Correct?
Yeah. Should I draw that or?
Okay, now in this case, if you notice, chlorine, if you go by the bonding capacity,
Yeah.
it is 1.
Okay.
Oxygen bonding capacity is 2.
Mm-hmm.
So oxygen should be in the center, right?
Yeah.
Okay, so there is a concept called as expanded octet, right?
Yeah.
When you have elements which belong to period 3 and ahead,
Okay.
okay, they can have more than the bonding capacity.
Okay.
Okay, so remember the example is elements which are belonging to period 3 and ahead,
Okay. So,
not for the first and the second period.
okay.
There is no exception to that. But if there is an element which is from third period and ahead, then
Okay.
it can have more than one, like more than the what you say, bonding capacity. Okay,
Okay.
and for that, what I do is I use a rule that from the given structure,
Mm-hmm.
the element which is least in number will be the central atom,
Okay.
except hydrogen and fluorine.
Okay. So from the central.
From the given structure, for example, this is ClO3, right?
Mm-hmm. From the given structure.
Yeah.
Yeah.
So we have ClO3. So we have one chlorine and three oxygen. So
Yeah.
my central atom will be chlorine.
Okay.
And I told you the exception to this is hydrogen and fluorine. Even if they are least, I will not consider them as central atom
Okay.
because those are
Mm.
monoatomic in nature.
Okay. Hydrogen and fluorine are never like the central atom.
Yeah, hydrogen and fluorine will never be the central atoms because they are monovalent.
Okay. Okay.
Okay. So now chlorine becomes a central atom.
Okay.
And the same rules as we did earlier.
So oxygen forms a double bond with chlorine.
Oxygen forms a double. Does it like? Do we need it?
Uh,
See if there is a need. We have Cl
yeah,
and we have three oxygens, right?
yes,
One, two, three.
yeah,
Then we give the shared pair, right? And then we
mhm,
complete the octet.
yeah.
Okay. And have we consumed all the 18? We have 26 electrons, right?
Yes, I think so. Yeah.
Or we
Okay.
have 24. Two electrons are still remaining and the octet is not complete. So we'll give the two electrons to chlorine.
Okay.
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 So that becomes your structure.
Okay.
Okay. Yeah, let's conclude for today and connect next week.
Okay. Sounds good. Okay.
Okay.
Bye,
Bye.
sir. Bye, sir. Have a good day.
You too. Bye.